Today I'm going to present a study that I conducted with Uri. We've been collaborating on that for quite a lot of time, actually. I'm going to start just by giving you the outline of the talk. So at the beginning I'll speak a little bit about neuroscience and free will, and then go to some definitions and assumptions, describe the study, and summarize what we've done. So we are all familiar with these types of studies, all showing either with EEG, fMRI, this is also EEG, or single units, that there is activity in the brain that precedes one's conscious urge to move. And as we all know, this has been taken as evidence against free will. And to simplify it, the agonizing of Hamlet or other, people like us that are agonizing over very strong and big dilemmas like to be or not to be should in fact be abandoned, because we already find neural activity in the brain that precedes these deliberations, and they may not be important for the decision-making process. And this, of course, has philosophical, moral, and ethical implications, and has made attracted a lot of scientific attention also outside academia. Now, we think, Louis and myself, that there are many reasons to criticize this type of thinking. The first being the double subject fallacy, and I won't have time to go into that, but it kind of agrees with what Petra talked about yesterday, this differentiation between me and my brain and the personification of the brain as if this is an additional subject that operates alongside my conscious self, which we think is some kind of dualistic thought that found its way into neuroscience. But today I'm going to focus on the operational definition of free will that was found in most of these studies, and the exception is Patrick's study that he just presented now, but usually these studies are unreasoned. And we went back to the dissociation made by Ullmann, Margalit, and Morgenbesser in the 70s, in which they differentiated between two types of decisions. One is a picking decision, so imagine that you're going to the supermarket and you already know that you want a specific brand of a milk bottle, and you have many milk bottles that are completely identical with the same expiration date, and you just pick one randomly, and it's unreasoned. You don't have any reason to prefer one milk bottle over the other, and in most cases it won't have consequences because they are all identical. Or you can think of a situation where it will have consequences, let's say if one of these milk bottles is poisoned or something, but you don't have any way to reason your way out of the decision. So this would be a picking decision which is unreasoned and non-consequential in most cases. On the other side, we have choosing decisions, where you go to the supermarket and you don't know which brand you want, and you don't know if you want the 3% or the 2%, and you don't know if you want the cheap one or the expensive one, and then you have to reason your way out of your decision. So now you're making a choosing decision which is reasoned, and in most cases is also consequential. And then going back to the studies that I mentioned before, we actually realized that they are not asking the questions like to be or not to be. They are basically asking their subjects to decide if they want to move or not to move. And we think that when it comes to free will, this may not be the question that we are interested in. So if we want to study free will, we may want to try at least to extend our scope and include also meaningful decisions and see whether we find the same activations when we are not only probing meaningless, arbitrary decisions, but also meaningful ones. So going back to this picking-choosing dissociation, we noticed that almost all the literature in the neuroscience of free will is focused on picking decisions, while we have a big branch or field in neuroscience that is focused on choosing decisions, which is neuroeconomics. And it seems as if free will, the people in free will are less interested in choosing decisions, and the people in the neuroeconomics field are less interested in consciousness and the brain and the relations between these two things. So we thought, what happens if we try to combine these two fields and try to compare picking versus choosing, or arbitrary versus meaningful, deliberate decisions. So how do you do that? How do you create a paradigm that will allow you to compare these two types of decisions while being very controlled and similar in all other respects. So our solution for that was to focus on monetary decisions that people make, to which organization they want to donate money. So we pre-selected subjects that defined themselves as socially involved. They said they volunteered at least 3 times that year, and they considered themselves to be very socially oriented. And we, at the first stage of the experiment, just presented a list of organizations, real organizations. They could go into their website if they didn't know them, and see what they do. And they just had to rate how much they would like to donate money to these organizations. And you can see that we had these more central organizations where most of us would like to give money to, but we also had controversial organizations, because if you would like to give money to Planned Parenthood, it's likely that you would not like to give money to a pro-life organization, because their goals are contradictory. So then we had the ratings for each subject's preference for these types of organizations, and we could create a paradigm that would be suitable for, tailor-made for each subject based on their own preferences. And then we had the deliberate decisions, or the choosing decisions, where basically I would present 2 organization names, and these could be organizations that you liked or rated equally similarly. So, for example, the Hunger Project and the Global Fund for Women, which for a specific subject only differed in 1 point. So they were relatively close in terms of preferences. And we also, that was a hard decision, and we also had easy decisions, and I hope this is easy for you as it is easy for me, where you have to decide to which organization you have to give your money to. And our condition, or our definition of an easy choice, was a choice in which we pitted 2 organizations against each other that were different in at least 4 points for that subject's ratings. So now we have a choosing condition where you make an easy, or either an easy or a difficult, hard choice based on your own ratings. And that would be a deliberate decision. Now I failed to say that when you make your decision, let's say that I choose the Hunger Project, then you know that this trial would enter into a lottery, and at the end of the experiment, we would choose one trial, one choosing trial, and the organization that you chose in that trial would get $40. And in addition to that, at the end of the experiment, we have a big lottery between subjects. And the subject that would be chosen, who would be chosen for that subject, the trial that was selected in the lottery, would actually lead to a $1,000 donation to one of these organizations. And we did give $1,000 to the chosen organization. So subjects knew that their decision is not a hypothetical one. It's a very real decision that could potentially lead to a $1,000 donation to one of these organizations. And that was very important for us, because we thought that if we would only present hypothetical choices, then at some point it wouldn't be a true choosing decision. We wanted subjects to be very engaged and to understand that their decisions have true consequences. So that was the condition, the choosing condition. What happened in the picking condition? So in the picking condition, you were presented with exactly the same choices, but now, whatever you were required to press either right or left, like in the previous condition. But now, whatever you pressed, both organizations got $500 if this trial would have been included in the lottery. So now you have the exact same visual input, because in each trial you present 2 names. You have the exact same motor output, because each trial you're making either a right or a left response, but the meaning is utterly different. In the choosing trials, you're actually making a deliberate decision to which organization you want to donate, and it is reason-based, as Patrick suggested before. But in the picking condition, you are basically making a random decision. It doesn't have any consequences, and we ask you, we say, please ignore the values that appear on screen and just randomly press either right or left. Now, there is, of course, a concern with that, because if they would ignore what's written on the screen, we would have also different cognitive processes. So in order to control for that, we had a memory trial, memory probe that was inserted every few trials, in which we asked subjects to report what was written on the screen, what were the organization names in the previous trial, just to make sure that they are allocating attention to the organization names on the screen, and they are processing the information and not just, they can potentially close their eyes and press right or left. So we had, it's basically a 2x2 design. We have picking and choosing, we have easy and hard, and this is what happens. This is how the experiment looks like. So this is a choosing condition, where you have the two organization names and you're making your choices. And that would be a picking condition. Now this is for $500 each. And you see the two organization names, and every once in a while you get the memory probe, which will appear now, in which you're asked what was presented in the previous trial. It looked like maybe one more trial to wait, or two. If it doesn't arrive, okay, and then you get the memory probe. So that was the paradigm. This is what happens. And this is a schematic depiction of it. So you have a deliberate block, you have an arbitrary block, and every once in a while you have the memory trial. So now what about the behavior? The first step is to make sure that subjects were indeed following our instructions, and that they were able to make choosing and picking or deliberate and arbitrary decisions. So this is the behavior. Let me just explain what you see in this figure, because it's not a very common one. So each dot here is an individual subject. In the red dots you can see their behavior in deliberate blocks, and in the blue ones you can see their behavior in the arbitrary blocks. And the histogram here just summarizes where, or sums, where all the distribution of these individual subjects with respect to the diagonal. The x-axis is reaction times in hard decisions, and the y-axis in easy decisions. So just to give you, to illustrate, so this particular subject, when he made deliberate decisions, it took him or her 2 seconds for easy decisions, but almost 2.5 seconds in hard decisions. So if all the subjects are on the diagonal, it means that they did not behave differently in easy and hard decisions. If they are below the diagonal, they were slower in hard decisions, and above the diagonal, they were slower in easy decisions. So one thing that is very clear from looking at this figure is that in the arbitrary condition, subjects are on the diagonal. They do not differentiate in their reaction times between easy and hard decisions, as one would expect, because we told them to ignore the value. But in deliberate decisions, you can see that subjects, almost all the subjects besides these two, are substantially slower for hard decisions than they are for easy decisions, which is exactly what one would expect. You can also see that they are faster in arbitrary decisions than in deliberate decisions, which again is what you would expect. When you look at their consistency with their own ratings, are they consistent with the ratings that they gave us at the beginning of the experiment? Again, you see, I would dare to say even textbook behavior with respect to the manipulation, because in arbitrary decisions, they are around 50%. So they are around chance, both in the hard decisions and in the easy decisions. Notably, there are some subjects, especially in the easy decisions, that find it hard to ignore the value of the decisions, but still they are around chance. While when you look at the deliberate decisions, then in easy decisions, they are at ceiling. So they are almost always consistent with their own preferences. When you have a 4-point difference, you always choose the organization that you rated higher. And when it comes to the hard decisions, you can see that they are fairly consistent, between 60 to or 70 to 80 to 90% consistent with their own findings, with their own ratings, which also makes sense, right? Because now this is a difficult decision. You have the Hunger Project or the Pro Women Fund, and it was a 1 point different. You may want to change your mind. So the behavior reassured us that the manipulation worked. Now what happens to the neural activity? Will we find the famous readiness potential not only for arbitrary decisions, but also for deliberate ones? So I'm going to show you the single subject data, because I think, especially in our day and age with the replication crisis, it's very important to see the single subject and not only the means. So you can see that in both arbitrary conditions, in the easy and hard decisions, we see a nice readiness potential in both types of decisions, not for all subjects, as you can see here, but for most. What happens in the deliberate decisions? Well, this is what we got. You can see that there is, the lines are, not all of them, but many of them are completely flat, with no sign of a readiness potential in deliberate decisions. And this is how the mean, and here when we conducted a linear regression to see whether we can find a slope, there is a significant slope here, and there is no slope in deliberate decisions. This is how the mean and standard error data looks like. Again, you can see a nice readiness potential in the arbitrary condition, and the scalp distribution is also what you might expect, though a bit lateralized for some reason. But in the deliberate condition, this does not differ from baseline, and the distribution also does not look like any readiness potential that we know. So the basic finding is that there is no readiness potential in deliberate decisions. Now one could ask many questions to see whether this dissociation indeed holds. One thing you might say, perhaps this depends on the response, because subjects sometimes use their right hand, sometimes use their left hand. So when we analyze the trials, we divide them according to right and left hand trials. You can see the exact same pattern occurring again. Another thing you can ask is, does this stem from the difference in reaction times? Because as I've said, subjects were indeed slower in the deliberate decision. So perhaps this slow reaction time somehow makes the readiness potential average out or something. And when we look at, so in order to tackle this question, we conducted two analyses. The first was just to divide the subject to a median split. So we took the fastest subject in the deliberate decision and the slowest subject in the arbitrary decisions. So now, if this is, and now their reaction times is fairly similar. And if this is only a result of the difference in reaction times, we should see no difference now between the conditions. But this is not what we find. Although we have only half the number of subjects now, we again see the readiness potential in arbitrary and not in deliberate decisions. We also try to correlate the difference in reaction times with the difference with readiness potential and found no correlation. Another concern was that this could be just a different motor response. Maybe something different is happening in the deliberate condition. So to account for that, we looked at the lateralized readiness potential, which is considered to be a purely motor response, which is computed by the difference between the voltage, in the C3 and C4 electrodes in right and left hand trials. And you can see that here we don't have any difference between the deliberate and the arbitrary trials. So what is going on here? So again, we turn back to Aaron's model, and I only have 2 minutes, so I won't go into the details of the modeling. And in any case, Uri was the one, I'm not a computer scientist, so Uri was the one that was in charge on the model, for the modeling part. But just to explain what we did, we took Aaron's model and we adopted it to our needs. So in our experiment, we had a decision that is congruent with your rating and a decision that was not congruent with your ratings. We took Aaron's model and we just had now two models that were racing against each other. So I should do it actually at the same time. They were racing against each other, and the one that reached its boundary first was the decision that we considered as the decision that was being made. So if you crossed the threshold for the congruent decision before you crossed the threshold for the incongruent decision, that decision won. So it was a race to threshold model, and what Uri did was he found the parameters of the model based on subjects' real reaction times and consistency rating, and found the parameters of the model for each condition. And to make a long story short, especially since I don't have the time, now after we found the specific parameters of that model, we could try to simulate what would the EEG look like if we are only focused on the noise component of the model. So now we take the model and we make a prediction of how the EEG should look like, again, if we are only recording from the noise component that the model included, and this was the prediction of the EEG. Now to remind you how the real EEG data looked like, it looked like that, which is quite similar. So we think that this model again based on Aaron's suggestions, actually shows, in line with your way of thought, that the resonance potential is indeed some kind of an artificial accumulation of noise or fluctuation. And this type of accumulation occurs in meaningless decisions, where the noise drives the decision. But in meaningful or deliberate decisions, the noise is not the sole operator that drives the decision, but rather the value mechanism is the one that drives the decision. So then when we lock the signal to the decision, as opposed to the random condition, the noise would not be at its peak. It would average out, which is why we don't see the readiness potential. So, according to that interpretation, we find the readiness potential in arbitrary decisions and not deliberate ones, and we think that this challenges previous accounts of voluntary action and the general ability of this finding to what we think are perhaps more interesting and more relevant decisions with respect to the free will debate. And I will just end with that. So we think that existing findings against free will should be revisited. And this is the general point. I think we all agree because we are all here. I think one lesson that this study taught me is that it's very important for us neuroscientists to also draw from philosophical work, especially in this type of questions and field, because philosophy can sometimes show us where we might be perhaps a bit off in our rational definition, or at least have to consider other forms of defining the phenomena that we're interested in. So thank you, and I'm sorry for taking 2 more minutes.